Hey guys, the journal article I chose to do for October is called "The Aging Clock: Circadian Rhythms in Later Life" by Suzanne Hood and Shimon Amir at the Department of Psychology at Bishop's University in Montreal, Quebec, Canada. So the thing that attracted me to this paper was it kind of covers all the different aspects of aging and the circadian rhythm, and I like that it kind of is a broad cover of all of it, so you kind of get some answers about some things. And then I came across this article because of the biological rhythms class. So the study looks at key age-associated changes in the circadian rhythms of behavior, physiology, and molecular processes. They also try to come up with a central hypothesis of what underlies these changes and summarize the evidence for putative mechanisms of action. This question is important because if you can figure out mechanistically what is going wrong or what is changing, then you can possibly manage it or introduce some sort of stimulus that can alleviate the changes that are not preferable. For instance, cognitive, not being able to think as well in the afternoon, which we'll get into later. The methods for this article, so this is a review of other articles, and the article did state that the vast majority of research in this area is cross-sectional. As such, differences in dependent variables between older and younger individuals that are attributed to age could potentially reflect cohort effects or other confounders, and it is potentially mitigated by the numbers of studies reviewed. So that's their kind of preface on it. So the primary results they covered a bunch of different areas, so I'll go through by category. First, they looked at activity and rest rhythms, and they summarized that adults in their 60s and above are significantly more likely to endorse a tendency for rising from and retiring to bed earlier than adults in their 20s and 30s. And the preference for morningness in older adulthood is expressed in other aspects of behavior, such as cognitive skill performance. Then they next addressed impaired phase shiftings. So they summarized that following a phase advance, older adults exhibited decreased sleep efficiency, self-reported alertness, and amplitude of the core body temperature rhythm that persisted for longer compared with younger adults. The next one is sleep, and they summarize that consistent with transition to a morning chronotype in older adult humans, the circadian phase of sleep onset and wakening advances with age, whereby older adults report preferred bedtimes 1 to 2 hours earlier on average compared with younger adults. Older adults experience significantly more awakenings and have longer latencies to fall asleep and spend less time in stage 3 and stage 4 and REM sleep compared with the younger adults. So pretty much sleep in older adults isn't as good, and they can't go to bed as easily. Then they next talk about temperature rhythms, and they say that in young adults, core body temperature rhythm normally peaks in the early evening and reaches its nadir in the early morning. In older adults, the period of the rhythm remains stable, but however, the amplitude of the rhythm decreases in older adult men by 20% to 40%, such that the nadir core body temperature does not fall as low as in younger adults. So there are changes in temperature. The next one they talk about is the melatonin and cortisol levels. It says that total melatonin secretions declines with age, beginning perhaps as early as the third decade of life. Reported a lower nightly melatonin peak in middle-aged men, mean age of 57 years, with cognitive impairment compared with age-matched healthy controls. And there were significant reductions in melatonin synthesis and expression of melatonin receptors in the SCN, and have been documented in individuals with neurodegenerative diseases such as Alzheimer's or Parkinson's. The next topic is metabolism and inflammation. So they summarize that dampening of these rhythms is suspected to contribute to increased risk in older adults of metabolic diseases such as diabetes, dyslipidemia, and hypertension due to chronic inflammation because of the lack of being able to maintain that circadian rhythm. Then the next part of the article, they go into the possible mechanisms. I'm not going to go super deep into each part, but they did have different topics they covered. So the first one, they said there's possible changes in the SCN. And the next is there's morphology and neuropeptide expression changes. They say the age-related change in the neurochemical makeup of the SCN, in particular, arginine, vasopressin, and VIP. And studies in mice suggest an age-associated reduction in the density of GABAergic synapses in both the core and shell of the SCN. The next possible mechanism they think is neuronal coupling in the SCN. And they say the age-related declines in overall coherence of the output signal from the SCN causes weakness or desynchronization in downstream oscillators. Pretty much the nerves aren't firing as well as they should, or they're not synchronized. The next thing they said that could cause it is changes in clock gene expression in the SCN. And then the last is Zeitgebers that could change, such as light, metabolic cues, food, or desynchronization of the downstream oscillators from the master clock. And then to summarize, why do I think these results can be applied to my own patients or situation? For patients I'm seeing right now, it is important to understand what might be at their peak, when they might be at their peak during the day, maybe even to schedule appointments when it might be best for them, and when they're thinking at their best. And it's also important to know that their cognition can change during the day and generally with aging. So as if I see older patients, I should understand that they may not be at their best as they get older, or certain times of the day for certain people. And then I can potentially recommend to my older patients to eat strict timed eating patterns, which may help their rhythms. That way there may be some utility in my practice to help these patients, maybe to help time their rhythms, since it has been shown that timed eating can help their rhythms. That is it. Thank you.